All right. Good morning, everyone. We're going to get started. It's good to see you back face to face. So we're going to continue today through the building blocks. But before we dive in, I have a few things to take care of as far as announcements go. So first thing, I told you last time that I was on the fence regarding IE1. I didn't want to just like send out an IE1 exam that would be kind of like empty, meaningless, busy work. Okay. So here's what's going on right now. With what we covered so far into building blocks, etc., we have some material that is actually very testable by quizzes. Okay. The IEs, I want to save them for asking you to write code from scratch and stuff like that. And we are this close to that. Okay. Well, this week, we're going to finish module 1. Then we'll be able to start meaningful intermediary exams that are going to be in line with what you have to expect for the final exam. Okay. So instead of bombarding you with a meaningless IE, we are going to do something different this week. I added something that I've been experimenting with in other classes, and that seemed to be helpful to at least some of the students. You're going to let me know if that helps you or not. I'll call you at some point in the class to see if we need to ditch that kind of quiz or not. But it's a new type of quiz. It's what's called cooperative quiz. So cooperative quiz doesn't mean that everybody's going to go around one computer and submit only one answer. Okay, I mean, you can do that, but well, but that means that there is going to be some exchange of information among the students, okay? And the exchange of information is going to be controlled by the software. Let me not make it sound mysterious, and let's just show you what I'm talking about, okay? So we have the same way that we have a GQ01, okay, which is a traditional, can come from the textbook test bank quiz, and it's already been released, and the PQ is preparing you for it. The same way that we have GQ01, we are going to have a CGQ cooperative GQ01, where you guys are going to be able to work to a certain extent together to solve it. It's hosted not on Canvas, so you have to go to this URL. You have to sign up with your official email address. Please make sure you use your official email address. That's the one that ends with @usf.edu, okay? Sign up for a free account on this third-party app, and then make sure that you put also your first and last name as they appear in the gradebook. All of that to ensure that you get credit, okay? And don't worry, I will upload the slides as usual as a PDF, and I will upload the recording of this video, so you'll be able to just click the link in the PDF itself if you want to, okay? So your grades in Canvas are going to be automatically fed by this application. So you are going to take the quiz on this third-party application, and then once everybody is done taking the quiz, then we are going to turn on the grading, and we are going to progressively fill in the blanks in your gradebook. So if you look at your gradebook, you have two new items that I added this weekend. One is called CGQ01 Step 1, and the other is called CGQ01, you guessed it, Step 2, okay? So these are where your grades are going to appear. These links are also in the module section. You don't even have to click on them. They don't do anything. They are just there. They are placeholders so that your grades are in Canvas, even though you are taking the quiz on another application. How is this going to work? So these are going to be short quizzes between 1 and 3 questions, very short, okay? That should not take more than 5-10 minutes. This one has 3 questions, so let's say 15 minutes maximum, okay? You're not timed. You're not timed, you're not proctored. You can go in the quiz, open it, look at it, scream, run away, close the tab. As long as you don't submit anything, you're okay, all right? So you can come back later, reopen it, say, okay, it's not that bad, submit your answer, and then you're done, okay? So these are very flexible quizzes. They are going to be worth like a small part of your grade, okay? But they are really flexible, very, how to say, my goal is not to test your knowledge. My goal is to make you think about some problem that in the past, I've been catching off guard students. And any way I can get you to think through those and get like a correct answer, it's a win-win for both of us, okay? So the way this is going to work is you have a first deadline, Step 1 by Thursday, 11:59 p.m., okay? So you go at that URL after you signed up, You are going to find a list of quizzes. You select the first one, 2512 CGQ01. That should be the only one showing up right now. You click on it, and it looks like a regular quiz. You have 3 questions. You have multiple choice for each question. You select the one right answer. And then there's a little kink into that quiz, okay? Every time, let's say I have 4 options in a question, and I select one. For the 3 options that I did not select, the quiz is going to ask me to provide what's called a justification. It's a text box, right? And you type like 1, 2 sentences. You don't have to like write like a whole text there. Some students do, that's fine. That's appreciated. If that helps you, that's good. But you have to just clear up your mind and tell me exactly why you didn't take that answer. Force yourself to not just pick at random, come up with justification. And you have time, right? You open the quiz, you close it, you open the quiz again, you say, okay, I'm going to think about this one, close it, you come back, now you're ready, you give me your justification, right? So if I choose 1 out of 4 options for a question, I have to type 3, 1 or 2 sentence type of blurb to explain why I didn't pick up the other ones. And then I submit. You are going to be graded on both the correctness of your answer. Well, yeah, that's kind of like what quizzes do, right? But also, you're going to be graded on the meaningfulness of your justification. What does that mean, meaningfulness? That means that it's participation-based. I want you to think. So if you show me a justification, that's wrong. You didn't select the right answer, and you're explaining to me right now why you didn't select the right answer. But as long as you put some thought into that, you're going to get credit for this, okay? The idea being that, yes, sometimes you're going to get it wrong, but at least you didn't just pick randomly, okay? You're going to get graded on those 2 parts, and that's going to be step 1. So if we have step 1, that means we have a step 2, right? Step 2 is going to be due the next day. That's crazy, right? No, it's not that crazy, because step 2, when you connect again to the server there, once I switch the quiz from step 1 mode to step 2 mode, what you're going to see is you're going to see the same 3 questions. You're going to see the answer that you selected during the first round, okay? And then what? For each possible option, so for each of the 4 possible options, including the one you selected, including the wrong one, including the right one, right? You are going to see a few of the justifications that your classmates entered to help you rethink about the question, okay? To help you take into consideration perspective that maybe you didn't even think about. And this is your chance right here to peruse through those justification from your peers, maybe give them a like or something like that if you think it's useful, and then make up your mind. Do you keep your original answer for each question? Do you change one of them? Do you change 2 of them, etc.? Even if you don't change anything, even if you say, I was right all along, these guys are full of it, their justification, I don't buy them, that's okay. You resubmit, and you are going to also get points for your second submission. So you have 2 chances to get it right, and you have some participation points to actually try to think, take the time to think about the question, not just guess and randomly click, okay? So we're going to give this a try. This is relatively new. This is based on research on peer learning and stuff like that, okay? That's one of my research interests, so I kind of try to apply that to my classes, kind of walk the way that I talk. But it worked relatively well in COP2513 last semester. So that's why I'm trying it with you also. I say relatively well. What does that mean? That means that the software is fresh. There's still fresh paint on the wall. Last semester, we had a few bugs here and there. Hopefully, they have all been squashed. If you bump into any problem, don't waste your time. Just post on Piazza, say, hey, this is not behaving normally. Something is weird. I cannot get my stuff done, etc. We will help you out right away, okay? But I hope, finger crossed, I'm going to totally jinx it, but I hope that this semester, we're not going to have to deal with any bug whatsoever. No bug at all. There you go. I did a good job jinxing. Okay, so that's it for the little, like announcements, logistic stuff like that. Where are we at? We're going through the list. We have like two more building blocks, okay? So we'll see how far we can go today, but if we're lucky, we're going to be able to wrap them up today. Building block 0, just sequence of code, sequence of statement, okay? Building block 1, well, some of those statements can be declaration, initialization of variable. building block 2, I change my mind, I want to change the value of a variable, I can reassign it later. That's all a computer can do as far as you're concerned right now. Okay, we're going to simplify things. This is all a computer can do. So no matter how hard the problem that you're trying to solve is, no matter how big the piece of code that's going to solve that problem is going to be, what I want you to keep in mind, especially those of you who are programming for the very first time, what I want you to keep in mind is I need to take a sequence of steps to solve a problem. And every time I'm about to take a step, it should be one of those things. That makes it from overwhelming, I don't know how to code, I don't know how to write a program, I don't know how to solve this problem, to, okay, which one of those steps could I take now that would bring me a little bit closer to my goal, okay? That's a totally different mindset. That's the mindset I want you to have when you write code from scratch. Building block 3, we may call methods, and we saw that their method, we call them, they do their job, we never hear back from them. Some method, we call them, they return a value. We can use that value in an expression. We can use that value to compute more stuff. And then there are methods that do both. You call them, they do something in the word right there, and then they send you back a result, okay? And that's where we stopped last time. But I have some unfinished business, okay? I didn't cover how we are going to do that kind of stuff when we write our own method. I didn't have time to cover that. So I'm going to start with that right now. So let's get into JGrasp somewhere here. There we go. So we have our good old live coding file here. I have a class live coding, a method do something. That's exactly the kind of method that we have been writing until now, right? Do something, public static void. So generally what we do instead of it, because we don't know how to do many things. So we just say, hey there, in the method, and that's it. And then the main, same thing. Generally, we end up calling that method that we wrote, because if we don't call it, why did we even bother writing it? I can call it like several times and get it to display its message, do its work several times. So if I run this, hey, there we go, okay? So now what we added at the end of last session was, well, okay, so there are some methods that you call. They have what we call a side effect, meaning they display something on the console, they write something in a file, in a database, send information on a network, retrieve information from the network. All of these are called side effects, okay? They change the world, or they change at least another computer system, the state of another computer system, or even just your console. And then they return, and that's it, end of the story. So we know already how to write those kind of method. The second type of method that we talked about, the one that returns something, we haven't done that yet. I just need to introduce one new Java keyword to you so that you're able to do this. And the Java keyword is easy to remember because it's called return. So that kind of makes sense, okay? Sometimes we have keywords that are a little bit technical, jargon type obscure. This one is not obscure at all. So what I would like to do is, for example, write a method here. I'm going to keep do something, okay? Actually, no, I'm going to keep do something like it is so that you have an example of that one. And then I'm going to say, well, I want another method, and that method is going to be int value equal get me a magic number. The goal of that method is just to return a magic number, whatever that means, okay? Return a number. It's going to return a number, and the way I use the method, the way I call it here, and I take whatever it returns, and I assign it as the initialization value for that variable that I'm declaring here. So all of this whole line here is a building block 1, right? Declare initialize a variable. The part where I initialize a variable is a building block 3. Call a method, and more specifically, a method that returns a value to you. So how am I going to write this method? Well, let's start with what I know how to do, okay? Even if it's not 100% appropriate. So public static void, so get me a magic number, and then open curly brace, close curly brace, and method, and I'm already seriously regretting picking up that name, okay? So there we go. So here's my method. I have nothing in it yet, but at least this code should compile. I tried. It should compile, yeah. And of course, I didn't make it so that it can return anything yet. So the compiler is telling me that. So yeah, I was a little too early with the compile button here. I need to change something so that I can use it like that, because actually that's interesting. What is the compiler telling me? The compiler is telling me error on line 17. So that's right here. On line 17, error, incompatible types. So we've seen that compilation error before. It's when I try to assign, like for example, a string of text to an int variable. It tells me the value is a string of text, the variable is an int. That doesn't fit. The value has to be the same type as the variable so that I may assign the value to the variable. So where is my variable here? Here, int value. So this can contain an int value. And then Java tells me the expression that you have here, that is supposed to result in a value that I may then assign to the variable, that also has a data type. What is the data type of this guy? Int? No. No. If you go through all the data types that we discussed, you're still going to get it wrong. What is the compiler telling you? I don't even need to scroll further. It's right at the beginning, yeah? Yeah, void. What's that void thing? So even if I don't know, always take a look at the compiler error message, okay? I know they are obscure at the beginning. First time you learn to program, compiler error message, sometimes makes sense. A lot of the time they are just technical jargon, right? But you are going to get used to that jargon. But you are going to get used by actually reading them and trying to understand them. Otherwise, you're going to ignore them all the time and you lose the help from the compiler, right? Void cannot be converted to blah, blah, blah int. So this as a data type, void. I've been using the keyword void here, here, and if I scroll up, my first method as well. So what's going on here? When you declare a method, you start with public static, and that is not going to change for this whole semester, okay? COP2513, we are going to change that. Public static, the name of the method, parentheses with potentially some parameter there. We're going to talk more about that. The code of the method between curly brace, and void right here. Void is a special data type. It means nothing. So what I'm declaring here is I'm declaring a public static method named getMeAMagicNumber that is not going to return anything. And that's what I've been doing since the beginning. So since the beginning, by putting void here or here or here, what I'm saying is this method does not return a value. So it's the first type of method. The ones that you call, they do something, and then they return to you, but they don't return with a value, okay? If I want my method to actually return a value, I'm going to have to tell the compiler, hold on a minute, this public static getMeAMagicNumber method returns an int. So int, Boolean, double, these are the three data types that we have been using, okay? And now we have that data type void that is very special. That data type void, you cannot declare a variable of type void, because it's like saying I have a variable of type nothing. So in Java, that doesn't fly, okay? But void can be used in front of the name of a method to say, this is a method that returns nothing. And if you use another data type, like int, Boolean, double, that means your method will return, before it completes, will return a value of that data type. You just signed a contract. This is a lot of what's going on with the compiler, right? I tell the compiler, public static void, get me a magic number. Then I try to use get me a magic number like if it was returning a value. The compiler yells at me. Now I say to the compiler, okay, public static int, get me a magic number. So when I try to use get me a magic number here, the compiler is going to say, okay, this is a call to a method. That method is supposed to return an int. The programmer is trying to assign that int value that's returned to a variable of type int. Check. The compiler lets me do that, okay? But there's one last thing missing. So let me try to compile that and show you what I'm getting yelled at for now. So I'm getting a different error now. So it's no longer, the incompatible type, because I fixed that. I told the compiler when I declare the method, it will return an int. The only thing that I forgot to do is to actually return an int. So this is where that new keyword comes into play, the keyword return in Java, return 42. So return followed by an expression. So an expression, again, you know what that is, right? It's like a variable name. It's like a literal value, an arithmetic expression with literals, variable name, maybe calls to method that return values as well. It can be arbitrarily complex. Here, just it's a literal value, the value 42 as an int. I return a value here that is of type int. The value of type int is assigned to a variable of type int. These are all the things that the compiler checks for you. At every step of the way, it double checks the right value is returned based on what you said you were going to return. The right value being returned is assigned to the right type of variable based on what you said. So all those verifications go on in the background when you compile, and now it's compiling okay. And if I did here, get me a magic number, and then system.out.println value, I would get myself a little piece of code that's going to display 42 on the screen. Okay, you understand how that works. A lot of what I'm telling you is what the compiler checks for you. And again, if you're coming from a different programming language, like Python, the compiler in Python checks a lot less things for you. It's not going to be constantly annoying you like Java, why are you doing this? Why are you doing this? But it's going to let go because it's assuming you know what you're doing. Java is a little more strict. It doesn't trust 100% the programmer. It knows we make mistakes all the time. So it tries to understand as much as it can based on what we write and try to infer, make inferences, make deduction, and warn us before things actually break. All right. Okay, so what we have now is we have the syntax to return a value from a variable. Generally speaking, what I would encourage you to do is, and this is going to be coming handy for coding bat exercise, okay? In coding bat exercise, you will always be asked to write one method. So they won't ask you to write the whole code, the public class, etc., the main method, etc. No. You will only be asked to provide the code for one of the methods of the application. And then coding bat is going to take that method, is going to stitch it in the server with a main, with a class, etc., run the main on that method, trying to make it work on a bunch of different parameters, and tell you how it went. I tested your method. Here's what comes out of it. Okay, that's going to be the routine with coding bat. So all of your methods in coding bat are going to return one value. Okay, that's how the exercise are built. What I encourage you to do is, if you have a method that's supposed to return an int, inside the method, declare a variable result of type int, okay, and then return result. Is that really different from what I did? No, it's still doing the same, okay? If I try to compile it, except if I made a typo somewhere, there we go, it's going to still do the same job, except that here I return 0, of course, instead of 42, okay? So why do I ask you to do stuff like that? Because as you just learn to make more and more complicated code, I would like for you to follow a pattern where when you have to write a method that's going to return a value, the first thing you tell me in that method is, this is a variable where the result is going to be, eventually. And you set it to 0, for example, if that makes sense. And then here, in the middle, you are going to have, I don't know, 2 lines, 3 lines, 50 lines of code, who cares? You are going to have code that's going to perform whatever the exercise asks you to do. And the goal of that code is to change the value of the variable result to whatever the result should really be. And that can be arbitrarily complex. And at the end, when you are done doing your internal computation, you figured out what you want to give, you know it's stored in the variable result, you just hand it over, return result. So that might seem a little arbitrary, okay? Please bear with me. This is a clean way to organize the code, but yes, we could do things differently. We could have a bunch of return statements inside the code right here in the middle that pretty much say, as soon as I figured out the solution, return it, okay? What I'm doing here is when I figure out the solution in my code, I store it in result, then I wait, And when I reach the end of the method, I return that value. Please do so for, like the next few weeks. As soon as we get comfortable with putting a bunch of conditional statement, loops, etc. together in a code and looking at multiple ways to return from a method, then we'll do that. But right now, all of your methods on coding bat, they will work if you follow that pattern. Declare the result, figure out the result, return the result. So you should have one return statement in your method at the end. Not because Java wants to. Java is okay if like every other line is a return statement, as long as it makes sense, okay? But just for us to ease into writing methods that might have multiple ways of completing, okay? All right, so we have a pattern here to get us out of trouble every time we want to write. Yeah, go ahead. Okay, so in Java, there are only methods. The F word is not allowed in Java, okay? The difference between method and function, okay, most programming language, including Python, that has both, okay, will tell you, or JavaScript, they will tell you a function is something that takes parameter, is a piece of code that accepts values as parameter, as data, does something, and return a value. That's the pure definition of a function, okay? We start talking about method when you write functions and you put them inside of classes. So it's just a terminology thing, okay? If I write a function like this is a function, right? Takes nothing, but returns a value. So I could call this a function, but because it's declared inside of a class, in all programming language, when a function is inside of class, we call it a method. And in Java, I would say, well, to be sure, 100% of the method we are going to write together are going to be method. They are going to live inside a class. They cannot be outside a class. Now, if you do a little bit of advanced Java eventually, you are going to find out that Java has also functions. That is methods that are not inside of class that you can throw around, pass around, kind of like what Python does. That's a different topic, okay? But for at least the next 2 semesters, yes, every time you bump into a quote-unquote function in Java, you can safely call it a method. That's the accepted terminology by everybody, okay? Good question. So keep in mind, okay, I have at least 2 different audiences. You could say that everyone is different, but if we group in category, I have people who are programming for the first time, people who program in another language. Both of you need to ask me questions, okay? I always try to gear my first explanation, like if you never heard of that stuff before, but if you already heard of that stuff, you need to connect it to what you already know. So you need to ask me questions like that, like for example, in Python I did that, why is it different here, what's going on? So that it helps you kind of like make the synthesis of both language, and then as you keep going, this is going to get easier, right? The third language you learn, etc., all of this is going to get a routine pretty much. But we are working on getting you to that routine, getting you comfortable. What else do I need? So I have a method that returns a value. That value is kind of dumb. It's always the same. It's always 0 or 42 or whatever I decide to put there. But we are going to fix that soon. Actually, we can fix that even right now. Get me a magic number. So let's say that we change this and we say ask for a number. So ask for a number, I change the name because this time I want to ask the user for a number, okay? So this is going to be a little less silly of a method. Instead of just returning always whatever result was here, I'm going to say, last time we learned to read values from the keyboard, right? So what if I did that inside my method? What if I said inside my method, scanner s equal new scanner system.in? That's a magic formula to declare and initialize a scanner variable named s, okay? Just go with it, learn it as a recipe right now, okay? And then I said I can ask the user system.out.println, enter an int value. And actually, I'm not going to do a println, I'm going to do a print so that then the user can type at the end of the line. And then I'm going to read s.next int, like so. And then I'm going to assign s.next int to result. And then I'm going to return result. So if you remember last time, right, we declare and initialize a variable s of type scanner. Now we tell the user, we give a prompt, okay? do something for me, enter an int value. Then we call on the scanner variable, we call the method nextInt, which reads an int value from the user. Everything that typed until enter is interpreted as an int. That value is returned, assigned to the variable result, and then I return the variable result. So if I had a piece of code where I was reading from the user, enter a first value, enter another value, enter a third value. Every time I do that, I would have to repeat at least those 2 lines, right? Well, now I have encapsulated, and actually the term encapsulated has a meaning in programming. We'll talk about that next class, right? But I have encapsulated into that method all the junk, all the details that are required to actually read a value from the user. So that later on, inside the main, I can, every time I want the user to give me a value, I just call ask for a number. I don't even have to declare a scanner in the main anymore. I don't need a scanner in the main. I need a scanner in the method ask a number, just because that method is going to interact with the keyboard, right? So I'm kind of like pushing things on the side, separating things, right? My main looks super clean. Ask a number, display that number. My method that ask a number has all of the little details in it that are relevant to being able to read something from the keyboard. But that stuff is not polluting all of my code everywhere. I'm putting things in neat little boxes so that eventually I can forget how ask a number works. I just need to remember that I call it, it reads something from the keyboard, an int, and it returns that int, and then I'm good. As we are making user interaction a little bit more complicated, as soon as we learn about loops and stuff like that, we are going to be able to encapsulate that in our method and do it one time in our code and not have to worry about repeating that code over and over and over. So let me try to compile this, get rid of typos or stuff like that. There we go. And if I run it, enter an int value, 42, we entered 42. Very simple stuff, okay? But it's not what we do that is relevant here, it's how we do it, okay? So we do trivial stuff so that you guys don't have to even use half a neuron to understand what's going on. You read 42, you display 42, that's trivial, right? But I want your attention all here. This is trivial, this is what is actually interesting. Okay, so this is a little bit less silly of a version of a method that actually returns a value. This time, it doesn't always return the same value. It go and do some work, okay, ask the user for a value, read it, and then returns it. All right. What is the next step for us? I'm going to introduce that now because it kind of fits with the flow and is going to be necessary for coding BAT, okay? What is the next thing we can do with a method? Let's say we have a method like this one that returns a value, okay? It does something and return a value. Maybe I want to give it some information. I don't have any way right now to give data to a method that I call, okay? I've showed you already. If I have whatever variable in the main method, those variables are not accessible from the code of the method. The variables that are here, they are not accessible from the main. So it's like the main and the ask for a number method, they are two programs that right now are almost independent. They have their own variables. They cannot communicate in any way except that the main can call that method ask for a number, which is going to do its job and return a value. So returning the value is the only channel of communication right now for data. Call the method, get a number. Call the method, get a number. What if I want to call the method, but I don't want to always ask enter an int value? Sometimes I want to ask, tell me your age. Okay, assuming it's going to be given to me as an int. Sometimes I want to ask, tell me a number that you're thinking about. So I want to change the prompt, the text that I want to display here. How can I do this? So what I would like to do is go here and say, for example, this is going to be his age. Be able to use this space between the parentheses, just like I did with system.out.println, to pass to the method, to give to the method some data to consider as it does its job. I want it to know that the message I would like it to display is, what's your age? There we go. So if I do this and I try to compile, again, all the checks, what's going on? Java is trying to figure out, are you really calling the method the way that the method is supposed to be called? Well, if I scroll back up just a little bit, the method up here tells me you call ask a number, you get an int in return, and this means no parameter, empty parenthesis. Here, when I call it, I call ask a number, I expect an int value as a return, but I also want to give you one value as parameter, as argument, okay? So when you declare a method, you have to set the rules of the game. So if you want that method to be able to accept data, to accept one piece of data that is a text, for example, you have to declare it like you would declare a variable. You declare the parameters between the parentheses like you would declare variables in the code, in a block of code. So here, for example, I can say string. So this is also a data type, but this is kind of a data type that I'm leaving as much as I can on the side because it's a little bit more complex than int, double, and boolean. Okay, but we are going to get to that one very soon as well. I want to declare a parameter here that says string, and I'm going to call my parameter with a name that starts with P to remind me this is a parameter, and I'm going to call it P message, parameter message. So now the way that Java reads this is, oh, you are declaring ask for a number, it returns an int, and it takes exactly one parameter, the number matters, okay? One parameter, which is of type string. And I'm going to refer to that parameter as message, P message, okay? So P message is like the name of the parameter. Does the main method know about P message? No. Like all of the variables here, the name of the parameter is only relevant in the code for the method where it appears, where it's declared, okay? So all of this is like the cooking details for the method, yeah. So good question. The question is if I try to run that, it's not running, it's not finding the scanner, it's because I cheated. All right, there we go. If you had that line, and I completely forgot to actually point it out when I was writing the scanner, but I had it already at the beginning because I get tired of having those errors and having to add my import, etc. So when I use like a file, for example, for live coding, you're going to see me do things like import java.util.scanner, import java.util.arraylist when we start using them. You know, I have all of my little toolkit at the beginning like that, okay? But you need to do that, otherwise, yeah, it's going to give you the symbol not found scanner. I don't know what a scanner is. I don't know what you're talking about. All right, so going back here, let's try to compile this. So symbol not found value, that's my fault, is because I changed age here, but I didn't change it there. So there we go. Well, it's always the fault of the programmer. It's really rarely the fault of the language. So now it's telling me and still enter an int value. So why is it still reverting to the old message? Because this is still what is in the print statement here. So if I want to use that P message, and it's like a variable, right? It's a parameter. A parameter is a form of variable. If I want in my method to be able to use P messages, I just have to use this name right here. So now that means when you call the method, you are going to tell me what should go inside the parameter string P message. So it's kind of like a variable, but it's going to be initialized when the method is called. So when the method is called, I call it with a little thing, what's your age? This is assigned to that. And now I can use that, and I'm going to display the message that you gave me. So if you keep changing the message, I will keep changing what I am displaying. What's your age? 42. There we go. It displays again 42. Okay. So now I can call it from the main, and I can do things like, for example, let me cut and paste just because I'm lazy. And I'm going to say, give me a value. What comes after 5. Very quintessential questions there. And then I'm going to display. This is what you gave me. Run it. So this is what's your age? 42. What comes after 5? Of course, 27, etc. So this is the first example. And I use a technical term, but it's okay. You can forget it until COP2513 if you're getting overwhelmed with jargon, right? But the technical term is encapsulation. This is your first example of encapsulating code. And all of you who already wrote a function in Python or JavaScript or whatever language you use, you did that. This is one of the primary mechanisms that we have in programming to not go completely nuts. Imagine that we didn't have methods. We keep writing code, writing code, writing code, writing code, writing code. My main method is now 20 pages long. Nobody wants to touch that with a 10-foot pole, okay? Yes, we work regularly on huge quantities of code, but to keep our sanity, we need to be able to say, okay, wait, I have like 1 million lines of code, but you know what? Those 50 lines here, all they do is ask a value to the user, make sure the value was correct, do all those checks. You know, if the user enter a wrong value, ask them again to re-enter the value. There is like a box here, a neat little box called ask a number. And once I remember what ask a number does, I can, to a certain extent, forget how it does it. And this is how we keep our sanity. We make a little box called ask a number. That's a method. We make another method that's, for example, opens the connection to the database. Another method that actually writes some text that we give it into a SQL query and sends it to the database. When I use those methods, I don't have to remember the SQL query language. I can just call those methods. I know they are going to update my database based on the information I give them, right? So this is how we write code, and then we build code that uses that code, and we build code that uses a code that uses the first code. And progressively, we can like kind of pretty much bury into the ground the complexity of many of the aspects of our application. And at a given time, we focus on one thing. For example, right now, my concern is I'm going to ask a number from the user, and I'm going to send it to the database and get, for example, all the employee records from the database that correspond to employees that have that age, the number that was given to me by the user. I can think of that task in a high level without remembering my SQL, without remembering how I use a scanner and stuff like that. And then once I wrote the code in the main, for example, then I'm going to change position. I'm going to say, okay, now this is done, but how do I read a number from the user? And now all my mind focuses on is a small task at a time, okay? We always focus on one small task at a time, and programming languages give us the intellectual tools to not only write code that is, you know, encapsulated like that little segment here or there, but think our way through problems like that, okay? When I have to solve a problem, I'm going to write my main method. I'm going to do this, this, this. These are like 3 high-level tasks, okay? And then I'm going to figure out how to do this task. And maybe to do that first task, I'm going to say, I need to do this, this, and that. And these are 3 other lower-level tasks. Every time we call method, we write method that do one job, and that's it, and do it well, and that's it. So it's not only syntax, it's also a way of thinking. What if I say I want several parameters? And that's it. We just need to learn how to use a method that returns value with several parameters, and then you'll be all set for coding that. So let's do that right now. What if I want a method that's going to ask for a number, and I'm going to specify the text I want it to display on the screen when it asks the user to enter some value, but then I'm going to also give it a value. And if the user enters that value, and I'm going to kind of get us bootstrapped for the next part of the slide, right? If the user enters a correct value, I want to just display something. It's kind of like an Easter egg. If you tell me your age is 42, and I was wired to say something like, you know, yeah, when your age is 42, then there you go. All right. So how do I do this? So let's forget about do something. We're not using it right now. Let's focus on ask for a number. Let's look at how I want to be able to use it. I want to be able to say, what's your age? And specify here my Easter egg value. Let's call it like that. If the age entered is 42, I want the method to say, hey, I recognize you. It's whatever on the screen. So 2 parameters. If I try to write it like that, the compiler yells at me. So when I call ask a number, the compiler tells me error, method ask for a number in class, live coding, so variables, cannot be applied to given types. So when the compiler tells you I cannot apply the method to the given types, that means you gave me some data, one piece of data, comma, another piece of data. The types of those 2 pieces of data are string for the first one, int for the second one. I cannot find a version of ask for a number that would work on a string and an int. And if you look, yes, you only declared a version of ask for a number that takes 1 parameter of type string. So when you call a method, the number of parameters that you pass needs to match the number of parameters you declared. The type of each parameter that you pass has to match the type of each parameter you declared. And yes, the order matters. So if you declare ask for a number takes a string and then take my Easter egg value, so I'm going to put a comma after this and declare an int Easter egg value, right? If I say that my method takes first a string and then an int, every time I call it, I need to be sure to pass first a string value and then an int value. If I do that, Java is going to be able to find the method and run it for me. If I don't do that, it's going to tell me, I cannot find the method that you're talking about. It's that simple. So if I try to compile this here, it's going to tell me, method ask for a number in class live coding, blah, 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 blah. It doesn't match, but hold on. This one is fine. The error is on line 23. So now it's telling me, you used to have a method that took 1 parameter, a string, but that method has been modified. Now it requires 2 parameters, a string and an int. You cannot call it with just a string. So you see how strict that is, right? It's not like some things are going to be assumed, that they have default value or stuff like that. It's like, you wrote a contract, you told me this method requires this and that, you better give me this and that every time you call it. So I'm going to put here an Easter egg value of 6, okay? When I do that, it compiles. Well, if I run it, it's not going to do anything new, right? There we go, 42 and 6, it just displays. But now I could use this value here to do something in the code of my method. So I could say, for example, I could say I read the number and then I display system.out.println. Too bad you did not type. And then I'm going to, so print, sorry, println. And then I'm going to type at the end of this line, system.out.println egg. So I'm pretty much saying to the user, oh, too bad you didn't type, that magic value that I was aware of, and I would have done something super cool if you did. But since you didn't, I'm not going to do anything. So what's your age? 45. Too bad you didn't type 42. What comes after 5, 6? So this one I didn't modify yet. And if the only problem is that if I run this and I do type 42, actually, well, it's kind of dumb, right? It tells me, like, too bad you didn't type 42. So what we need now, we need a way to get in there and to say, I don't want to always display this message. I want to display this message if the user entered a value, result, that is different from egg. And that's one of the 2 missing building blocks that we need to introduce, okay? So the 2 missing blocks that we are missing, kind of redundant to say that, but the 2 missing blocks that we still need to cover are conditional statement, condition, if a condition is met, is true, then execute that block of code. Else, execute that block of code. That's the before, building block number 4, conditional statement, okay? And the last one will be loops. So let's dig in. So Conditional statement, there is a syntax here, okay? So in this case, we have a little program as a number equal to 0 that's going to be provided by the user. We have a scanner. We ask the user, give me a number. So it's pretty much what we are doing, right? Number equal s.nextInt. If number equal, so double sign equal here. Please pay attention because at least I would say half of you are going to mess that up at some point. 1 equal mean assign a value. 2 equals mean compare. Compare this to that, and if this is equal to that, then this expression is true. So it's a Boolean expression, a comparison expression, okay? If the number variable contains a value 42, then here's a block of code. That block of code is to be executed only if that expression is evaluated to true. What do we do? System.out.println, you know the answer already. Okay, you gave me the right magic number. Else means if that condition was false. So there are only two possibilities with a Boolean expression. It can be true or it can be false. There's nothing else in between, right? So if it's true, you execute that part of the code. If it's false, you execute that part of the code. So if is a branch in your code, okay? Until now, it was always execute a statement, then the next statement, then the next statement, the next, and then we learn a statement can be declare a variable, assign a variable. We learn to read stuff from scanner, etc. So we have choices, right? But it's been always one thing after the other. Here, when we execute this statement, and this is your entire if statement, okay? It's what we call a composite statement. It's a statement that contains blocks of code. So it contains more statements inside of it. So when you look at that if statement, only half of it is going to be executed. Which half? It depends on this condition. That's it. All right? That's all there is to know about a conditional statement. So now I can go back to my code. So a few remarks before I go back to the code, because going back to the code is not the most important thing. A few remarks here on the structure of those conditions. Again, we are trying to start easy. So until the end of module 3, all the conditions that you will have to write in coding bat, etc., are going to be this simple. Okay, it's going to be always compare something that can be the content of a variable or a full expression, compare something to something else, another expression that yield also a value. Okay, the comparison that we are going to be able to do are equal, same thing, lesser than, lesser equal, greater equal, and this symbol here that is exclamation mark equal, with no space in between. Okay, that means different. So this is equal, this is different, and the other ones are kind of like self-explanatory, okay? So we have 6 possible comparisons that we can do. Every time we do an if statement, we're going to compare 2 things and try to figure out if the comparison is true, execute this code. Else, if it's false, execute that code, okay? All right, so that's it for the if statement, very easy, okay? Every time you write an if statement, I'm going to ask you to be careful. And again, this is just to avoid, things that I've seen take time to people. That's time wasted. When you write an if statement, this is how you write an if statement. I wrote the entire statement, and it's empty. There's nothing in it, okay? And then I go back here and I say, for example, if the result, which is what the user typed, is actually the same thing as the value egg, then I want to display, you did, I don't know, whatever. Yeah, there you go. Let's be creative. System.out.println. Oh, oops. Thank you. As you can all see, I don't know if I said that, but that would be funny. As you can all see here, I'm doing this and this. So what I was saying, what I was not showing, okay, is you type, your if statement like this, empty, right? But you type it out, you close every curly brace, etc. And then you go back in and you fill the blanks. So the condition first, what am I testing? I'm testing if result is the same thing as egg. If result is the same thing as egg, println, yeah. Else I want to display that stuff here. So I'm going to grab this, going back here, put it there, indent, and that's it. So now I want to end run and continue. There we go. Now, when I run this, if I say my age is 45, with numlocks, that would work better. It's going to say, too bad you didn't type 42. If I say, run it again, my age is 42, then it's going to say, yeah, okay. Conditional execution. Conditional execution of one block or the other. Only one of them gets chosen, okay? Depending on whether the condition is true and false. You cannot have both parts of the if statement execute in the same run. Every time it's a decision, every time only one of them gets executed. What is the last building block? And with that, you have everything. You are what we call in computer science Turing complete. Congratulations. You have universal computation powers, meaning that anything that can be computed by a computer, you can actually write a program that's going to compute that thing using only those 6 building blocks. Sounds crazy, but yeah, it's not going to be a pleasure. I didn't say it would be fun to write, complex program, complex pieces of code with only 6 building blocks. But my point is that in the whole thing of programming, if you think about programming as I'm trying to solve algorithmic problem, theoretically, any problem that is actually algorithmic, any problem that can be solved by a finite number of precisely detailed steps, they can be solved with those 6 building blocks. So technically, you have everything you need to program. And we are going to work now, after those 6 building blocks are in your head, we are going to work on, okay, how do I solve problem? How do I take a requirement? How do I break it down? How do I translate human problems into code solution? And we are going to use only those 6 building blocks for a little while, module 1, 2, and 3. By the time you're warming up to the whole programming thing and doing so, in an easy environment, then we start throwing more building blocks, more complication, more syntax, so that you can do more things more easily. Okay? So the last one is iterative statement. To iterate, that means to repeat. Okay, so iterative statements are loops. With the conditional statement, we saw that there are statements that are composite. So my if statement contains 2 blocks of code, and the if statement decides which block of code gets executed when it runs. Looks at the condition, evaluate it. If it's true, this one. If it's false, this one. An iterative statement is going to also be a composite statement. It's a statement that's going to contain 1 block of code. And now the whole question is, how many times do I keep repeating that block of code? It's like me telling you, do a task, please. And then I say, by the way, can you repeat that task 5 times? I'm not going to tell you, do this for me, and then do this for me, and then do this for me. No, I'm not a robot. I'm going to tell you, can you do this thing for me 5 times, please? And that's exactly what we learned to write here. Instead of writing 5 times the same piece of code, the same block of code, we just write it once and we prefix it by something that pretty much says, do this n times, 5 times, 10 times, etc. All right, so we are going to have condition also. We are going to use a condition to figure out when it's time to stop repeating. Okay, as a matter of fact, we do it the other way around. When the condition of a loop is true, that means keep repeating. While the condition is true, keep repeating. When the condition is false, stop repeating the block of code, go to the next statement after the loop, okay? So you heard me say while. The while is the basic, most basic, simplest type of loop. That's the one we're going to use for now, okay? So module 1 to 3, you need to know if else, you need to know while. So you have one example of conditional statement, one example of iterative statement, loop, and you can do everything with those. And then once you're comfortable, I'm going to start teaching you about the other kinds of loops that the Java syntax affords you, okay? How does the loop code work? Well, in this case here, we have a variable, okay? So building block 1, declare and initialize a variable n equal to 5. This is going to help me keep track of how many times I need to repeat the task. And I'm going to decrement that variable. So it's 5, then I'm going to make it 4, then I'm going to make it 3, then I'm going to make it 2, 1. And when I reach 0, I know that I've repeated something 5 times. So it's a counter. It's a loop counter. We always refer to those variables like so, okay? Then we have the syntax of a loop. Syntax of a loop is while, parentheses, a Boolean expression. So just like if, parentheses, Boolean expression is a syntax for if, it's very similar for a loop. And then followed by one block of code. This is all the code that I want you to keep repeating again and again and again while that condition is true. All right. So my condition is while n is greater than 0. So n is 5 right now. I'm going to keep track of n here on my end, right? N is 5 somewhere in memory. I have the value 5 in the variable n. While n greater than 0. Is n greater than 0? Well, n is 5. 5 greater than 0. True. The condition is true. I execute all the code in the loop. Okay? System.out.println, displaying something on the screen. Bam, one time. N is, I change the value of n, building block 2. N is now n minus 1. What is n minus 1? N is 5, n minus 1 is 4. Now I assign the value 4 to my variable n over there in memory. Okay? So n is 4. I reach the end of the loop, the closing curly brace. What happened when I reach the end of the loop? I rewind. I go back to the beginning of the loop. But every time I go back to the beginning of the loop, that's when I'm going to test the condition. Is n greater than 0? Well, what is the value of n right now? 4. Is 4 greater than 0? True. Bam. Display again. Display something. N equal n minus 1. 3. End of the loop. Rewind. Is n greater than 0? 3 is greater than 0. True. Display something. N goes down to 2. Then again, 2 greater than 0. Display something. N goes down to 1. Then again, display something. N goes down to 0. Now, the last time I go back here, after I decremented n from 1 to 0, I go back here and I say, is n 0 greater than 0? No, false. It's not greater equal, it's greater, right? Greater strict. So this condition is false. What happens when the condition is false? I do not execute the code again. When the condition is false, I just go to whatever is after the statement, the loop statement. So the loop statement is going to repeat itself while the condition is true, and then when the condition turns to false, it's going to move on to the next statement that is after the end of the loop. So I'm going to get this kind of stuff on the screen. Now, this kind of loop is a special kind of loop. When do we know how many times we are going to iterate? Right here. Because of the way the loop is written, okay, when I run my code, when I declare and initialize n, I already have everything I need to know to determine how many times this code is going to spin around. 5 times. That's the goal of the loop. N starts at 5. I keep looping while it's greater than 0, and I keep decrementing it by 1 every time. If I change this, the comparison operator, if I change the value that I subtract, maybe I add 1, maybe I subtract 2, if I change any of those 3 parts, then my loop behaves differently, right? But the way it's written, whatever number I put here is exactly how many times it's going to run. So if you are capable to look at a piece of code, and right before you execute the first time, the while here, if you are capable to tell me based on the values in memory for all of the variable, how many times that loop is going to spin, we say that it's a counter-controlled loop. The goal of a counter-controlled loop is to use a counter to decide when to stop. So these are the loops that say, can you do something for me 5 times? Can you open and close that door 10 times? I have a CD by proxy. All right, so stuff like that. As long as you can be upfront and say, do something this many times, and the number of times is known before you enter the loop, it's a counter-control loop. And then the whole deal is just to make sure that we keep an eye on the counter and we keep decrementing or incrementing it. And when the right value is reached, we're done. These are the easiest type of loop. Again, your mileage might vary. The first time in your life you hear about a counter control loop, yeah, it's going to take like 5 minutes to get used to it, but it's still the simplest type of loop. The second simplest type of loop, a little less simple, but still, well-defined, These are called, I'm going to blurt out the name first, Sentinel controlled loop. The difference is we have a piece of code here that is not using a counter. Okay, that's not how we decide when the loop is over. This code here says the user is going to give me a value. This is going to contain the sum of all the values that the user gave me total. Okay, here's my scanner. While input greater equal to 0. So while the value that the user enters is a positive number or null, okay, 0, null, as long as the value that you type to your program is positive or null, I'm going to execute that code over and over. If you enter a value like -1 or any negative values, I'm going to move on to the next statement after the loop. Okay, and the next statement here is going to say, here's the sum of all the values that you entered, and then here's the value of sum. So this program is going to, inside this loop, ask the user to enter values, add them up together, and it's going to keep doing that while the value entered are not negative. When I'm tired of entering values, when I'm done entering value, I'm going to use a special value, any negative numbers in this case, and that's going to tell the program, I'm done with you. Okay, give me a number 5, give me a number 0, give me a number 6, give me a number, sick of it, -1. That's it. The program understood that we are done playing the give me a number game, and now it's going to display the total. Okay, so we call those Sentinel controlled loops. Okay, because they are going to read data from somewhere. So in this case, we do only one thing. Here, we read from the keyboard, okay? Later on, you'll learn to read from files, read from database queries and stuff like that. It's the same principle. So we use a simple one, the keyboard. So I'm going to read a value from the keyboard, and that's exactly what I do here. Enter a positive or null value, input equal s.nextInt. I get that value from the keyboard, put it in input, and then add the value input to sum. So everything I read from the user, I add it to my variable sum. So it keeps growing and growing and growing. When I reach the end of the loop, I say, oh, by the way, was that input value a negative number? Because if it was a negative number, I'm done. If it was not a negative number, if the user entered 3, 5, 7, 128, whatever, then I ask for another one. What's the next number? Give me a number, I add it to sum, go back here. Was that a negative number? Stop. It was not a negative number, continue. Okay? So that's the logic of this loop. So there are several things that characterize a Sentinel controlled loop. Okay? It reads data from somewhere, always. A file, an array, a list, anything, things that you didn't cover yet, it takes data from somewhere and look at every element one by one. And then that data has a specified range, meaning that, for example, I'm reading temperatures. I'm going to say the temperatures go between, this and this range. If somebody tries to input a temperature that is below 0 Kelvin, that wouldn't make sense. Not in physics as we know it, right? You cannot go below 0 Kelvin. Actually, I don't think you can even reach really 0 Kelvin. But anyway, don't quote me on that. Bottom line is each of the values that I read has an expected validity range. Like if it's a grade, between 0 and 100. And then we agreed, we meaning the user and my program, we agreed that if you give me a value that is out of that range, or if you give me a special value, like if you give me -27, that means you want to quit the program. This is kind of awkward. Okay, so it's easier to say if you give me any negative value, that means you want to quit. So we agreed that some values were valid in that range, and anything outside that range would be your way to tell me, done. I'm done with you. I gave you all the information I wanted to give you. Now process it, give me the result. So we agreed on a special value that is called our Sentinel. Sentinel just because you are on the lookout for it. So that doesn't really fully make sense, but please go along with it. It's been like that since I was a student. So you're looking for that special value, and when you see it in what you read, you know it's over. You know there's no more data, the user wants to quit, it's the end of the file, whatever, okay? So Between counter control and Sentinel control, what's the big difference? The big difference is that here, I don't know how many times I'm going to iterate. I just don't know. You can give me everything in memory, a memory dump of all the variable, and you ask me before we execute while for the first time, how many times is this loop going to repeat itself? And I'm going to tell you, it depends on what the user types. It depends on what I read from the file. It depends on what the database holds, okay? These are like outside external factors. So I cannot anticipate the number of iterations just by doing a little bit of math at this point. That's the main difference between counter control, where you determine, okay, I'm going to iterate 5 times, and now you know it, you start the loop. This one, you start the loop and you say, I'm going to keep going until it's time to stop. And I'll know when I see a Sentinel value, okay? Last, so this is Sentinel control loops. Last type of loop, last type for our last building block. So it's still a loop, it's still a while loop, so I'm still using the same syntax in Java, that doesn't change, okay? It's just the kind of loops that I write that changes, okay? So here, what I have is, I'm going to make it very easy for you. What I have is a loop that's going to actually, it doesn't even read anything from the user. It's going to generate a random number. So I'm going to explain a little bit about that in a second, okay? It's going to use this formula here, this yellow formula, to generate a random number between 1 and 10, okay? So this is how you can tell because there's a 10 here and a 1 here, right? It's going to generate that random number and it's going to add it to the current value of sum. So sum starts at 0, okay? I go through this. I say as long as the sum, the sum value is lesser than the max value, and I set the max to 23, completely arbitrary, I add a random number to sum. So sum was 0, now let's say sum is 3. Next time, sum is going to get a +4, sum is 7. Next time, it gets a +3 again, sum is 10. And I keep adding random numbers between 1 and 10 like that to sum until sum is actually reaching max. When sum reaches or exceeds max, I'm done. System.out.println, this is a sum that I get. So sometime I'm going to get 23 because all the number added up to 23, and this is when I stopped. Sometime I'm going to get 24, 25, 26, 27, 28, up to what? Up to 33. 33 would, no, actually 32. 32 would be the only, the maximum that could occur, right? I was this close to 23, I was at 22, and then I rolled a random number, added it, now I'm at 32. Yes, I exceeded 23, so I stopped. What's going on with this loop? Well, the best way to characterize it is to say it's definitely not counter-controlled. So we negatively characterize it, okay? We don't say what it is, we say what it is not. It's not definitely counter-controlled because when I'm here, I cannot guess how many times the loop is going to spin around. And it's not Sentinel controlled either because I don't read data from anywhere. That data, those values for that data, they don't have a valid range that has been mentioned anywhere. And there is no special Sentinel value that I should be on the lookout for. So pretty much, I say, if you find yourself with a counter-control loops, you know exactly what's going on. If you find yourself with a Sentinel control loop, you know exactly what's going on. And then, if it's not counter-controlled and it's not Sentinel control, honestly, I don't know what to call it. This is general purpose loop. That's just, loops happen. So this is a loop that maybe does a little bit of counting, a little bit of looking for a value, but it doesn't match exactly the definition of counter control or actually Sentinel control. Okay? All right. So with that, I still need to elucidate a little bit this, but you can use that as a recipe right now, generate a random number between 1 and 10, just plug in the lower range and the upper range here. And we're going to talk more about random numbers and then put all those building blocks together starting next slide. Thank you. What's up? Yes. All right, let's take a look. So